Welcome to EDU World Space.
In problem 72, we're given that the EMF is 72 volts. The resistor R2 in the circuit diagram below has a value of 2 ohms. The capacitor C1 has a capacitance of 3 microfarads, or 3 times 10 to the minus 6 farads, and C2 has 6 microfarads, or 6 times 10 to the minus 6 farads. The capacitor have obtained their final charges, so therefore they're assumed to be fully charged. And when they're fully charged, C1 has a charge of 18 microcoulombs, or 18 times 10 to the minus 6 coulombs. And in part A, we're asked to find the charge on capacitor 2. So I will be utilizing equation 24.1. So this is actually from the previous chapter, where you're given that the capacitance is equal to the charge over the potential difference. And in this particular case, these two capacitors are in parallel with each other. And in that chapter in 24, when you have two capacitors in parallel, they have the same potential difference between them. So let's write that C1 is equal to Q1 over V. So this is the common potential difference between the two capacitors, and C2 is Q2 over V. And let's continue to solve this on the next page. So I wrote previously that C1 is equal to Q1 over V, and C2 is equal to Q2 over V, because the two capacitors are connected in parallel. They have the same potential difference across them. And from here, we can eliminate V, because we don't know V, but we know C1, C2, and Q1, and that will allow us to find Q2. And let's actually eliminate V from this equation, then substitute into this equation. So V from here is Q2 over C2. And then we take this and put it into this equation, so that we have C1 is equal to Q1 over Q2 divided by C2. And let's just rewrite that a little bit. C1 is Q1 over Q2 times C2. And we actually want to find Q2s, so let's rearrange again, so that we have Q2 is equal to Q1 C2 over C1. And let's put in the numbers that we're given. So Q1 is 18 times 10 to the minus 6 coulombs. And then we have now C2, which is 6 times 10 to the minus 6 farads divided by 3 times 10 to the minus 6 farads. And this gives 36 times 10 to the minus 6 coulombs, or 36 microcoulombs of charge. So that answers part A. in part B of the problem, we're asked to find the resistance of the resistor R1 in the circuit diagram. So let's get the next page and let me reproduce the figure just so we can know where R1 is. Okay, so this is C1, C2, this is R1, and this is R2. And we're given this value, and we know these two values, and we have an EMF, which we also know. So we need to determine what R1 is. So we can now use over here. Okay, so we keep in mind that the capacitors are fully charged, and when they're fully charged, then no current will flow through this segment of the circuit that has the capacitors. So then we basically sort of have a circuit that a current is flowing this way between the two resistors. So then we can write that E is equal to I, the current, R1 plus R2. But we actually don't know what the current is, and that's something that needs to be determined. But we can use the fact that whatever the potential difference that the capacitors see, that is also the same potential difference that R2 will see. So we can solve for the potential difference in across any one of these capacitors. Since they have the same potential difference, there should also be the potential difference at this point. So let's say the potential difference of the capacitor C1 is Q1 over C1. And that is 18 times 10 to the minus 6 coulombs over 3 times 10 to the minus 6 farads, which is 6 volts. So there's a 6 volt potential difference here. So the potential difference, as I said before, across the capacitor is the same across this resistor R2. So VR2 is equal to VC1, which is equal to 6 volts. And now that we know that, we can use VR2 is equal to IR2 to find the current. And that tells us that the current is VR2 over R2. And when we plug in the numbers for this, we get 6 volts over 2 ohms, which is 3 amperes of current. So now we know the current. So we have this equation. E is IR1 plus IR2, and we know E, we know I, and we know R2, but we need to find R1, so E minus IR1 over I is equal to R2, which then tells us that R2 is equal to E is 72 volts, I is 3 amperes, R1 is 2 ohms, and we divided by 3 amperes, and this gives us 22 ohms, and that's the value of R2.